When I was 17 years old, I woke up in the middle of the night because my parents' house was shaking like crazy. And I had no idea what was happening, but because I was kind of half asleep, I imagined that perhaps a UFO with aliens had landed on the roof of my parents' house. When I woke up the next morning and realized that in fact it had been an earthquake that had been shaking my room, I was immediately fascinated and hooked by this idea. What I experienced was the now rather famous Vermont earthquake of 1992, which is still the biggest earthquake ever recorded in the Netherlands. But my curiosity in the earth dates back to a much younger age. And I think it's actually important to tell you the story of my whole life, really, because curiosity and ambition for research, when they're planted as seeds really early in your life, they are so deep-rooted that they can get you through those difficult times that we all experience when we're doing research. Those times where a paper gets rejected or a grant proposal that you're really passionate about doesn't get funded. And so my interest in the world around me, my curiosity dates back to when I was very young. And my favorite word as a 2-year-old was the word why. And I just drove my parents and teachers crazy, asking why about everything I saw. Now, my parents, they fed my curiosity and they gave me lots of different books about history and science. And I just want to show you my favorite book, which was called My First Book About the Universe. And actually, this book, the first part of the book was the part I read mostly, which was about the Earth. And I just loved this page where you could see how you could go on a journey to the center of the Earth. And so that's where some of my interest in the earth sciences comes from. Now, further, what really helped was that I had some amazing teachers in school. And I had this one teacher who actually gave me as the secret Santa or surprise, which is a common thing we do in primary schools, one of those square hats that professors wear, saying, I think you'll once wear one of those square hats. And also my parents, they gave me all the confidence that I needed. And I actually, when I was young, never the thought came up in my mind that things could be different for boys or girls. I just thought I could become whatever I wanted to be. And one of those things was I wanted to become a professor. So by the time I got to secondary school, things got a little bit more difficult. And like many of us, I met a maths teacher. I was really good at maths, but he didn't allow me to go to the Olympiad. He only asked the boys in the class to go to the Olympiad. And he literally said, well, you're a girl. You're very good at learning tricks, but you don't have any deep understanding of the mathematics behind it. Quite outrageous. But by that time, I was so confident that actually this only built my ambition to prove him and the other people wrong, that I could do maths and that I could become a professor in a theoretical subject. So this is what I set out to do. I was good at maths and physics, but I wanted to apply it to something that I could touch, something big. And so I embarked on a degree in geophysics, which is part of earth sciences, but partly in physics, partly in earth sciences at Utrecht. And I loved it. I really like the earth. I like earthquakes. I like the field work, looking at rocks. And I also became more passionate about wanting to become a professor. And I was also quite keen to go abroad. That little seed planted by the teacher when he gave me the square hat only grew bigger when I watched movies about universities in the US where people wear these hats and these long togas. And I wanted to do the same. I also was really keen to go abroad. So how do you actually organize that? How do you get organized going abroad as a student? And this is where I had one of those key changing moments in my life, where actually as a third-year student, I was invited to be a student assistant at a big geosciences meeting that was held, a big international meeting, thousands of people, that was held in The Hague that year. And I was there as a student assistant, just helping the presenters with their slides. And I remember sitting in the audience, seeing this amazing talk by a professor from Harvard and thinking, it's now or never. And I actually plugged up all my courage. I can still see and remember the feeling I had, the stress, but I did it. I put all my courage up and I went to this man and I said, can I come and do my master's project with you at Harvard? And to my surprise, delightful surprise, he was incredibly encouraging. And he said, yes, you can come. Now, in the end, I didn't go to Harvard, but this got everything going. And through some of the professors in Utrecht, I ended up going to Oxford instead, which was quite a similarly amazing place for my master's project. And I even went back for my PhD. And indeed, Oxford is a place where already you don't even need to be a professor. As a PhD student, when you graduate, you get to wear one of those black square hats and a nice colorful gown. So at least I fulfilled that ambition. So that's the story of how I get there. But like I said, it's also very important that you're passionate about your research topic. And what did I do? What did I work on for my master's project? Well, actually, I ended up working on a very challenging, but also very interesting project. I'm a seismologist, and what I do as a seismologist is that I use earthquakes that generate waves, and these waves travel through the earth, and I use these waves to make pictures of what the earth looks like. And I like to think about, following on from that picture that I so much liked as a child, I still envision my research as a journey to the center of the earth. So if you would start at the earth's surface, then you have a thin crust, which quickly changes to the mantle. That's all solid, the crust and the mantle, and they consist of rocks that you see at the Earth's surface, that mountains are made of as well. And in this mantle and crust, earthquakes and volcanic eruptions originate. Now, if you keep on traveling to the center of the Earth, then about halfway through, everything changes, and it changes from a rocky mantle to a metallic core. And this core is fluid. It consists of molten iron and nickel, and it's flowing really fast and generates magnetic fields. Now, inside, just before you reach the center, you have this solid sphere, this red sphere that you can see on the slide. And this is a solid inner core made of solid iron again. And my research project was about proving that that inner core is actually solid. And this is a story that dates back many, many years ago to 1936. And actually, it also led to my inspiration for being really keen to work on this project. So the inner core was discovered in 1936 by a Danish seismologist called Ina Lehmann. And I find this really an inspiration to learn about this female seismologist in Denmark who, against all the odds in those years where there were almost no women doing science, became a very famous seismologist and made this major discovery that there was an inner core at the center of our planet. What she couldn't prove, however, although suggest that perhaps this inner core could be solid, but she couldn't prove it. Now, the proof is a tiny wave that is really difficult to observe, and people searched for it since 1936. And when I embarked on my master project, it still had not been found. So I started looking for it, and this was like a proper jump in the deep end, because that was not an easy project. So immediately I had to learn with frustration, not finding quick results, thinking about how to do it, but in the end I came up with a way to actually make that wave visible. And then I learned another very important story as a scientist. If you make a new discovery, then people will be very critical. If they've been searching for it for 60 or 70 years, they will say, but actually you need to prove this, and we don't believe it because this reason, this reason, this reason. So I had to learn to deal with rejection and persevering, keeping on finding the more proof, answering all the questions. And only 2 years after first making that discovery, I finally managed to get it published. And this is another wise lesson. And I find it frustrating at the time, but afterwards I realized that it's actually often the case when you're on the verge of finding something new, that people will have more criticism. If you do rather boring science that people have done before you, there's not much to critique. But when you do something new, it's actually the criticism and all the questions are often a sign that you're discovering something new and exciting. So another example of how you can turn something around and actually really use it for the best. So that was my master project, and I enjoyed it so much, and I had this amazing professor I was working with, and I went back to Oxford to do my PhD there. And I just want to say that if there is magic between a PhD supervisor and a PhD student, then it's great. You can get really, really good science. And this professor became a very inspiring mentor for me. And he's also the one that taught me a lot of theoretical seismology. And what I did during my PhD was change topic. So I worked on the inner core for my master project, but during my PhD, I started working on the mantle, and I learned this new technique where you actually look at an earthquake by studying the whole Earth oscillations. Whole Earth is oscillating, and actually the maths and physics you use to do that is similar to that from quantum mechanics. So there I was proving wrong my secondary school teachers. And one of the backbones of my research, actually doing all this theory and developing new theory, taking the theory from quantum mechanics, the maths from quantum mechanics. We use the same maths to describe the oscillations of the Earth. The maths you use to describe the hydrogen atom is the same as the maths you use to describe the Earth. I proved them wrong, that I actually am now an expert in this theory and actually developing new theory as well. And I use this to make pictures of the Earth just like you can make a brain scan. So when you do your PhD and you finish, then suddenly you can have your own research ideas. And this is what I really enjoyed. I think it's really important. For me, it was really important to find my own personal fellowship after my PhD to prove that I had my own research ideas, and I was actually dying to apply my own research ideas. And I stayed in Oxford University College. And actually, when you are a postdoc there, you become part of the staff, and there you can already wear a gown during dinner. So even more, I really got my chances to wear a gown, not only for graduation, you even wear them for dinner. When you go for dinner at one of these colleges, you have to wear a black gown. And then you need to find your first academic position. Many of you will be in your tenure track, and I'm just going to be honest about it. I thought that starting my first lectureship, and I moved from Oxford to Cambridge, was one of the most stressful times of my life. I had lots of sleepless nights. I basically found everything I had to do for the first time stressful. I found it really stressful to set my first exam. What if all the students would fail? Or what if they would all get the highest mark possible and I totally pitched the exam at the wrong level? It was really quite scary to have my first PhD student write their thesis. What if the thesis wouldn't be good enough? Write my first grant, and actually it got rejected. And that was difficult. I found it really difficult that I got my first grant rejected. And there were some really nasty comments in it even. You know, just started in Cambridge, and that when you start, you're kind of on your own. And one of the reviewers said, well, I don't really know why she's trying to do this research topic. This doing tomography is really dominated by research groups in the US. There's no point to get this, to give funding to this research project. And it hurt me, but actually, again, after being upset about it for a couple of months, I finally plucked up the courage and I actually spoke to my mentors. And I think this is really important. When you are on your tenure track, you need mentors. You need some really big and famous professors to help you so you can tell them about your worries. Now, they won't write your grant proposals for you. They won't write your papers for you, and they won't give you research ideas, but they can help you with everything else. Yeah, they can help you with your questions. Shall I take on this extra job or not? And actually, the best advice these people gave me is get grants, write papers. Don't take on extra teaching responsibilities if you don't have to. Don't go on committees that you don't have to be on. If you want tenure, if you want to become a good academic, you need research and publications. So the first project got rejected, but then I went back to my passion and I actually wrote a grant proposal about the inner core. And that got funded by an ERC starting grant. And here I am. Here you see me with my research group that I built up in Cambridge. And actually, that research group was just as big as the biggest group in the groups in the US, and we were competing with the biggest groups in the US. There was a time where people said there is the group in the US in Berkeley, and there is Arwen's group in Cambridge. So we did actually do really well. Now, I could have stayed in Cambridge. I was on track there to become a professor. But then there was the opportunity to go back to the Netherlands. And I'm Dutch. And I had a daughter at the time. And I was just keen for her to grow up in the Netherlands. You know, there are lots of studies that show that Dutch children are really happy. And I just wanted to have her to have that happy childhood in the Netherlands. And actually, it's nice also to be back in the Netherlands. In the Netherlands, you have these wonderful ceremonies. So I became a professor in Utrecht in 2017. And one of the things I really enjoyed was giving my inaugural lecture and wearing a gown again and a hat. And these big ceremonies is something that we love having in the Netherlands. There are big ceremonies for your PhD, and they don't exist like that in the UK. My parents are still disappointed. They never got to go to a big PhD ceremony like you have in the Netherlands. So there are also a lot of good things about being back in the Netherlands. And I built a new research group in the Netherlands. And again, I must say, maybe you think the stresses are gone when you've got your tenure, but when you move to a place and people hire you with high expectations, thinking that because you had a grant before, you will get it again. That was another year of lots of sleepless nights, writing another ERC proposal and writing a proposal for NWO. But it all worked out. I got funded by a consolidated grant from the ERC and a VG grant. And here you see my research group in the Netherlands. Now you may have noticed that my research group in Cambridge mainly consists of girls. That wasn't by design, a little bit by coincidence, because I was the only lecturer there lecturing in physics, and a lot of the girls in that in the final year lecture I gave there, they enjoyed my lectures and they wanted to come and work with me, so they just came and wanted to do PhD projects. Now in the Netherlands I've got a few boys as well, so it's a little bit more in balance now. But I'm actually really proud because all the girls that I had in Cambridge, they've all got academic positions now. So I really moved from being mentored myself to now also mentoring my own research group. Now, listening to all these stories, you may think that the only thing I ever do is science and being an academic. But I really want to tell you that you need a life outside of academia. And you need a hobby and you need to do other things. Now, my big hobby is my ballet classes, and I love doing it. I love this second life I have, this other life, totally different from being an academic. And I love my ballet classes and all the dance performances we do. And even though you may think that, you know, this is time not spent on science, in the back of your mind, your brain keeps on working. And all those ideas you have find their places. And actually you need those distractions to become a really good academic. And last but not least, I love having my family. When I said as a girl in school that I wanted to become a professor, people told me you can't have it all. You either have a career or you have a family life. Now I have a lovely family, a lovely daughter and husband, and I take every single holiday. I take all the holidays we get in university, and please, I want to tell you, do the same. You need that family life. Only when you're a happy person in your private life, in your family life, in your with your hobbies, you can also be a good academic. The combination of your family life and your academic life will make you a whole person. Thank you.